record. All right. So this time we're trying to say that we know there are some characters in memory, right? Right here. We also know that string literal returns the address of the first character. Then, if we capture this type of integer, and if we're able to tell our programming language that please go to this memory, use this subscript notation, which is using square brackets every time you access memory, it's the way it is. And then we say that at this location, or use this location as a pointer to a character. So this location actually is pointing to a character, and this is how we want you to extract that character in memory and be able to display it. So let me also print essentially new line, character at the end. So and then save it and compile and run and see if that is successful. So it compiles. So far, no error messages. Control F5 to run it, and it does print this character A, which was expected, and it's quite an impressive result so far, that we're able to use, like, memory located someplace in starting with address 0, and we were able to say, okay, go from memory 0 address this far at that particular location, make sure you understand that this is a character, get that character and go ahead and display it. So we really use some low-level facilities. Now if you ask me whether this is a good way of using memory access, I'd say this is an interesting demonstration, but it's not very practical. So let's get a little bit more organized. So the idea is to say we want to use location in much less, I would say, heavy way. So we say let's location be a pointer to char, to character. But what does it mean? So essentially start the next attempt at this same type of challenge. Well, maybe we can say that, first of all, what is a pointer? What is it? Well, we can say that ideally pointer should be a variable. If it's a variable, right, should be, I meant to say, should be a variable, then such variable, right, such variable stores memory addresses, right? And obviously it can be used to access objects in memory. So here's this second attempt. We can say that perhaps this requirement of specifying what location is, in fact, a pointer to a character in memory, could be used as a declaration of this variable location. So I can say, okay, character location equals something similar to this, A, B, C, D, F, G. Okay, and this will perhaps this won't compile because I'm redeclaring location twice. Let's I guess what I'm going to do at this point, just comment out those couple of lines. Just keep them as a reference, but then comment them out right now so that they're not getting in the way. So what happens here is that we say location is a variable because this looks very much like a variable declaration. So location is a variable which is a pointer. In the declaration, this is pronounced as a pointer to a character. So that makes perfect sense. Location is a pointer to a character. Now, immediately, we could initialize our location with the location of the first character in this character string, because that's what character strings are designed to do. The memory gets allocated, populated with each character. The null character is also appended at the end of this, but as a result, this string returns an address of the first character. Well, it sounds like an address of a character is a perfect thing to initialize a pointer to a character, right? So interesting. So the next thing is that perhaps we can try this. We can try the same thing. We can now say, well, I guess I can copy and paste the entire statement, right, over here, because say, oh, okay, so let's show that character. So this time, I can ignore this, saying that, well, wait a minute, location already tells us that this is, not just any type of thing, but specifically a pointer to a character. So that should be understood as location is being used to go to memory at this particular location and extract a character, because it's already being built into this variable. Because remember, what is a pointer? Well, we want it to be a variable, but that can store memory addresses. But it happens to be also very, very useful that it can remember the type of data that it's pointing to. So let's try this. So let's run it. Build and try to execute it. So let me scroll this so that we see some of the code. Control F5, execute. And so it's successful, right? So we know we have something in memory. We use the square bracket notation, which is, by the way, an index or subscript type of notation. And we also well know where the memory begins, right? Let me try something else alongside with this little experimentation, that I can print the location on its own. Okay, so save that. So first I will print, we already know it's going to print character A, right? So then I will print the location itself, just to see how it looks like. Now, jumping ahead of time, I can tell you that cout is programmed to any time it sees a pointer, that someone is trying to display a pointer type, it will switch to hexadecimal representation of numbers, because that's more convenient to use as notation for addresses in memory. So that's what I'm expecting to see. Oh, in this case, again, it was slightly different compared to other types of pointers. That as soon as the cout saw that the location is a pointer to character, it was basically thinking that we're trying to give it this pointer, and it was thinking that someone gave the string to access and to be able to print. So that's why it actually printed the entire string. So let me try this example with a slightly different data type. For example, if I wanted to say integer of value equals 1, 2, 3. Okay, so I have an integer variable. So let's then try to comment this out so I can redeclare variables and everything. So this time I will change this and say integer. So this time I want my pointer to point this variable in memory, which contains some value. And this time, how can I initialize my pointer to point to this variable. I know that this variable is somewhere in memory, right? So there's a very simple way, is that we can say val, which is an integer variable, and we can tell val, give us your address. Any object, as soon as you get access to any object in C or C++, you can ask that object. In fact, the compiler will know where exactly in memory it's located, so it's a no-brainer. It's for the compiler, it doesn't matter whether the name was used for a variable or someone wants to use an address. It's like the second name for that particular value 1, 2, 3, right? So it's very easy to say, give me an address. So in particular, let me see how we do here. So let's finish this segment. So in particular, this this operator right here, this is an address of operator. Okay, so this ampersand is an address of operator, just like plus, minus, any other, like for instance, remember there are like increment and decrement operators. So it's another operator. It's so useful that the ampersand as punctuation was sacrificed to be used with objects in memory, in order to ask these objects, what is your location in memory? So let's try this, right? So we'll do exactly the same thing, Control C. And so this time what we're going to do is that we're going to go to our memory and try to obtain an object. This time we're pointing to an integer. And so I'm expecting 1, 2, 3 to be printed, because this is the syntax that says, go ahead at this place in memory, get there and extract the value. And we send the value to cout. It should be happy to print it out. But this time we actually should see the address. So again, build this, right? So build this and then try to run it. So here it is, 001 EFB94, okay? And 1, 2, 3 is printed as expected. So again, the result of printing this location is, except in the case with characters, where cout said, oh, you give me address of a character, I'm just going to assume that this is the entire string of characters, and I'm just going to show all the characters. In case of an integer, it just thinks, okay, they just want to see the address, and so it displays this address. So remember, 1 EFB94. Try it again. Control F5. 21 F7D8. Control F5. 027 FD F8. Different addresses. What it means is that it's one of the ways to scramble where the program loads in memory to in effort to combat viruses, so that viruses have much more trouble figuring out what to do and how to operate when every time program is loaded in a different location in memory. Well, of course, we're dealing here with virtual memory, but that's a different story. For our program, it's a real physical memory, and it's quite specific address. Yes, question.
The first